FutureMakers.
Hi, I'm Ro. I'm one of the coaches here at FutureMakers, where we design, test, and create playful hands-on learning kits called Sparks. Sparks are made to help educators like you integrate hands-on challenges and imaginative play experiences into your classrooms and learning spaces. Now, this video is made just for you, educators and specialists that believe in the power of playful learning. We recommend that you watch this before making the Sparks with your learners. I'll go over everything you need to guide your learners through an experience that builds confidence, sparks curiosity, and fosters collaboration. This approach has been tested with hundreds of learners and educators. We're sure that after you watch this video, you'll be confident and ready to spark playful learning in your communities. So get ready, let's play. These are all the parts that come with each Strawbot. To make the core build of the Strawbot, you'll just need 6 straws, this harness, this unbalanced weight, a AA battery, a rubber band, a motor with a gear attached, and 3 connectors. Now let's move away everything we don't need to make more room. Speaking of room, we recommend having a more open area for learners to tinker with their finished bots, like the floor in a corner of a classroom or a large table. So, let's create the body of our Strawbot. Lay out 3 straws in a straight line from end to end, and place a connector between each straw. Join the straws together into one long line using these connectors. Now, some learners have found that gently smushing the end of the straw like this makes it much easier to press the connector in. Now, let's make our battery pack. First, we'll pre-stretch our rubber band so that it's easier to use. Then we'll hook the rubber band onto the battery's bump and stretch to cover it end to end. Hold the rubber band over the battery so that the rubber band runs the length of the battery and covers both ends of it. Heads up, if the rubber band keeps slipping off the end of the battery, encourage learners to press firmly on the band over the bump while stretching it to the other side. Very small fingers may need help from others. Let's attach the battery pack. Insert one end between the battery and the rubber band, and carefully slide that halfway down that straw. Now to attach the motor. First, grab your foam harness. At the opposite end of your straw line, slide one end of the harness on like this. Place your motor in the middle of the harness and feed your straw through to the other end of that harness. Make sure learners do their best not to bend the straw at this part. Also keep in mind, the wires of your motor are very fragile and will break off if they're pulled, so be careful. Now this is an ideal moment to spot check our build. Make sure everyone has the battery and motor correctly attached to the straw. Now let's add a connector to an open end of our straw line, and then attach your unbalanced weight. Press the gear into the hole of the black foam weight. Make sure the surface of both the weight and the gear are smooth. Let's connect the body into a triangle shape. I can connect these straws into a triangle by bending the connector with my finger. We recommend checking in with your learners at this point too. Make sure their straws are connected in a triangle. We should have a battery on one side of the triangle and a motor on another side. Now, let's make it stand. Add 1 straw to each connector, making sure they all go in the same direction. And if my Strawbot is too unstable, I can always adjust the legs to make sure it stands. Now let's make it go. Gently slide a wire between the rubber band and the battery on each end. The big idea here is unbalanced forces and their effect on movement of the bot. If the weight had a hole in the middle, it would be a balanced weight, and when spun, wouldn't affect the vibration and the bot wouldn't move. Since the hole is on the end, rather than in the center, the weight pulls the bot in different directions as it spins, and therefore makes the bot vibrate and wiggle. Now to troubleshoot. Are the wires connected but nothing's moving? If the foam weight isn't spinning, check to see if it's stuck against a straw or if the motor gear is pushed too far into the weight's opening. Also, check the placement of your wires. In order to work properly, one of your wires has to be touching the bump on the positive end of the battery. Double check that your wires are secured at each end. Congratulations, your Strawbot is built! We recommend that learners start by playing on their desks, and if they need more space, they can move to the floor to see how far their bots can go. If you'd like to take this a step further, feel free to try out different shapes like squares, or combine two bots to make a hexagon. Thanks for watching. In case you didn't know, every FutureMakers Spark is individually packed so that learners can keep what they make and take it home. We believe that providing ownership of what they make helps to boost engagement, empowers them to take greater risks, and allows playful learning to continue anywhere. We're committed to ensuring a fun, creative, and playful experience for you and your learners. We've also created a playbook, which includes standards alignments, printables, a learner-facing slide deck, and more to make all of this quick and easy to prepare for. Check the description below for links to all of these materials or find them on our website. Let us know what you think. Bye!
Future.